This is a brief tutorial for the UCR-USV tool. The first step to run the tool is to install the MATLAB MCR in order to run the tool. So here we have the application, which is an executable file of our tool, and we have compiled it with MATLAB. So in order to run this tool, you need to install the MATLAB MCR on your computer, which is absolutely free. So if you just open the browser, so let me open the browser, you can just type MATLAB MCR and the first link is the MATLAB compiler runtime. If you click, then select this version R2013A 8.1 and install the 32-bit or 64-bit on your Windows. So either of the versions, depending on your what configuration is your Windows. Is it a 32 or a 64? You can just pick the correct version and install it on your computer. And our tool is compatible with Windows, and it's not compatible with Mac at this time. So after you install this MCR in your computer, you will see a MATLAB icon besides the UCR-USV tool. So you can double click on this application and it's going to run in a couple seconds. Alright, so here's the tool. The first section of the tool is extract syllables. What I'm going to do is, so the first input is the WAV file. If you click on browse, you can select the WAV file that I have included in the website. This WAV file was not inside the folder. I provided a separate link which you can download the sample WAV file. It's a sample of recording of mice vocalization that was provided by the neuroscience department at UCR. Then the next input is the destination folder. So you can just create a folder for the results. So this destination folder is going to contain all of the results produced by the tool. So I'm going to browse and select that folder that I created. Then the next step is to define the time of the process. So from the WAV file that we have selected, let's say we want to extract the syllables from second 100 to 103. So we just want to extract the syllables from these 3 seconds of the WAV file. And then the next input is the gap between the gap threshold for combined calls, which means that, so the default is 10 milliseconds. It means that any gap smaller than 10 milliseconds between consequent syllables would be considered as a combined call. So you can just leave it blank because the default is 10 milliseconds, and then you just have to click extract and it's going to extract the syllables. So if you go back to the results folder that you created, there's there's a folder with the same name of the WAV file. If you double click, you're going to see that a couple extracted syllables from the WAV file, from the audio file. So if you look at the labels of the syllables, the first number is the starting point of the syllable in milliseconds, and the second number is the ending point of the syllable in milliseconds, and then the third number is the lower frequency in kilohertz, and the last number is the higher frequency of the syllable. So for example, in this case here, the point is at 37 kilohertz and the point here is 79 kilohertz, and so on. So we have these labelings for these syllables, and you can ignore these 2 other folders. There's just they include some additional data that you don't need. This was the main one. Let's go back to the folder. Let's go back to the tool. There's another button called call rate. If you click, it's going to plot the call rates. So actually, the call rates is the number of the syllables that was extracted in every 1 second. So we use a sliding window of size 1 second. We slide it through the syllables and count how many syllables we have and during every 1 second. So for example, at this data point, it means that we count the number of syllables like half a second after and half a second before, and we have like 7 of them, and so forth. The next section, and then here there's another button called filter. So if you can just like mention the, so you can just view the extracted syllables, you know, and you can so here you have to define the size of the grid and how many, how many syllables you want to view in the page. So if you click filter, it's going to show you all the 10 syllables that were extracted, and then you can like pick some of them which you think are noise and throw them out of the data set. But anyway, you can ignore this feature, not a big deal. The next section is the basic operations. If you click on durations, it's going to compute the durations of the syllables. So here's the minimum, which is 33 milliseconds, and then here's the max and the mean. And a file is created here in the results folder, which is called duration. So if you open this up, you're going to see the durations of all of the syllables in order of time, and all of these durations are in milliseconds. Let's go back to the tool. The next button is frequency, so it will calculate the minimum, the lowest frequent. This is actually the dynamic range, so it's the upper frequency minus the lower frequency. So the minimum is 22 and the max is 44, and the mean is 32.6. And then here another file is created, frequencies. If you open this up, these are all of those dynamic ranges for the syllables. So the dynamic, and you can see like 23 is the minimum. 22 is the minimum. So if you go back to the tool, it's telling us, yeah, 22 is the minimum, the max is 44. And the last button is the other info. So if you click, it's going to tell you the total number of syllables, the average gaps between every 2 consequent syllables, and the maximum gap between every 2 consequent syllable. And then again, there's a file is created in the results folder, which is called gaps, and it includes all of the gaps between every 2 consequent syllables. The next section or tool is classification. So it's going to classify the syllables based on their shapes. In order to classify them, we need a ground truth table, a dictionary, in order to classify them. So some experts, for example, in our case, some of the neuroscientists from the neuroscience department extracted many syllables from the mice vocalization and then labeled them, and decided that, for example, how many classes we have of syllables based on their shapes. So let me go back here. So we have a folder called normalized ground truth, which is a couple. So you can see like 108 items are here, and these are actually the dictionary that were handpicked by the experts. So the first label is showing the number of the class. So you can see like multiple instances of class 1, and the same for class 2, and so on, and for class 11. So we have 11 classes and multiple instances for each class. So this is the dictionary that was created for mice vocalization. Obviously, for another species, another dictionary should be considered. But let's go back in this case. So here we have to select the dictionary. So it's the normalized ground truth, and I select the folder. And then here you can view the dictionary. So again, it's same as the filter option up here. You can just like view you can just view all of the elements in your dictionary. But you can skip this feature again. And then the next input is the thresholds for classification. So this file is provided here as thresholds. So if you look at thresholds, you're gonna see a set of thresholds that are set for 11 classes. I'm not gonna talk about the details how we get this, but if you want more information, I can provide you how we get these thresholds. And So I'm gonna input the file of thresholds, and finally the last input is the gonna be the label ground truth. So it just includes the labels of the the elements in the ground truth, which class they are in order, right? So like the first element is so in order of time, right? Because we have a lot of elements in our ground truth. So if we order them in time, what are the labels of the classes? These are the labels, right? So we totally have 11 classes. All right, so I'm going to go here and pick that label file in here and then click classify. So it will take a while to classify those syllables. All right, after it finishes classifying the syllables, you're going to see a summary of results here in the blue box. So it's showing that how many syllables we have for every class. So class 0 means that if a syllable doesn't get classified, it belongs to class 0. So one of them wasn't classified. And then here, for example, we have 5 of the syllables were classified as class 3. So if you go back to the results folder and let's go to class 3, you're going to see 5 syllables that are classified as this class, and they almost have the same shape. Or for example, let's see, we have 2 syllables in class 8. So if you go to class 8, you're going to see these 2 syllables that belong to this class. And finally, there's another button here, class numbers. So if you click on this, it's going to produce a file called list syllables class. So if you open it, it's going to show the time of the syllable and the class number. So this is sorted in the order of time. So for example, the first syllable is class 8, and then class 8, class 7, and so forth. Yeah, in the last section here is for adding some behaviors to the file that was, specifically used in our project. Yeah, that's it. That's all. And the last point is that for the for extracting syllables, we have tuned up our tool to extract them, from these mice vocalizations. So depending on the quality of the recording, the frequency of recording, we have to set up, we have to tune up our tool. So if you have problems, if you're not able to extract syllables and the tool is not extracting any syllables from your WAV file, you can just send me a short recording of your file, and I can tune the parameters and I can just make sure that it's extracting all of the possible syllables in your WAV file. Thank you so much for your time. Please let me know if you have any other questions. You can just email me. Thank you so much and have a good time.